In the name of Almighty Allah, the most gracious, the most merciful. As Muhammad, peace be upon him, narrated, if any man travels on a road in search of knowledge, Almighty Allah will cause him to travel on one of the roads of paradise. Hello everyone, this is Dr. Tariq Masood. Thank you very much for watching my videos and your wonderful support to make this channel a grand success. We are a family, a partner. Please share and subscribe our channel if you haven't done so far. We as a team can work together to convert challenges into opportunities and opportunities into success stories. These success stories can be monetized into value addition in the world by large. Thank you very much for your precious time. Okay, today I'm going to discuss my HAZOP study lecture number 8. HAZOP study guideline lecture number 8. Center of Excellence, governing a pathway, delivering on commitment, differentiated performance, enabling profit optimization process. Before my lecture, I used to read a Quranic verse. Qala Rabbi Shrahli Sadri wa Yassarli Amri Wahlal Uqdatam min lisani yafqahu qawli Allahumma Rabbi Zidni ilma. O my Lord, open my chest and ease my task for me, and loose or not from my tongue, that they may understand my saying. Allahumma Rabbi Zidni ilma, O Allah, advance me in my knowledge and true understanding. Okay, Center of Excellence, lecture number 8, HAZOP study guideline, section number 6. Okay, purpose of Center of Excellence. Okay, what through the Center of Excellence, what we have to do? First, where we are now. Number second, where we want to be. What to do and how to do. These are the 4 segments in order to deliver the results. Okay. Okay. Center of Excellence. Governing a pathway, delivering on commitment, differentiated performance, enabling profit optimization process. Okay. We have started the hazard and operability management system, that is HAZOP, section number 1. Next lecture, we are going to start hazard identification, then later on quantitative risk management system, risk assessment, and a safety integrity level assessment, or it's also known as SIL. So these segments will be discussed on later stage. Okay, these all segment I have already discussed my earlier lectures, defined not in detail. So each segment have a couple of lectures which we are going to deliver next couple of years. Probably it could be 200 or 300 lectures. Okay. Okay. If we can see here, this is a performance pyramid from bottom to top. These are leading factors: leading, semi-leading, semi-lagging, and lagging. Okay. So if we can see here, personal safety, co-worker, contractor, and community safety must be reliable. This is my leading factors. Okay. On the second stage here, that is environment, compliance, process and asset safety. So what we have to do, work safely or not at all. That's important. And number 3, production at plan, production specification. So there is always time to do it, right things in the right time. And then continuous improvement, that is my leading factor. So if it is worth doing, do it better way. Okay. So what we have to do, everybody should participate. A role of different discipline engineer: petroleum, chemical, electrical, instrument, control, mechanical, industrial, civil engineers. These are their specialty. Loss prevention, safety engineers, process, operation engineer, optimization, all discipline engineers, cohesion, integrity, reliability, cost, and project engineers. Okay. These are engineers based on their specialty. They have to deliver first to stop, to mitigate, or to control our leading factors. So these leading factors, if any leakage from the leading, it will go on the second level, third, and then you cannot deliver the result over here. Okay. So in order to have in specific and to achieve what we want to be, so then we need a center of excellence for engineering best practices to stay at the top of the pyramid. Okay. Key takeaway points HAZOP study. So first HAZOP are parameters, which I'm going to discuss today. HAZOP deviations and HAZOP record and action sheet. This is my last lecture on HAZOP study. Okay, first appendix 1 HAZOP are guided words. No, not, or none to complete the negation of the design intentions. Okay. What is common? No part of the intention is achieved and nothing else happens. Number 1. Okay. Number 2 here, more of the quantitative increase of any relevant physical parameters. Okay. These refer to quantities plus relevant physical properties such as flow rates and temperature, as well as activities like heat and reaction, etc. Okay. Number 2, less of quantitative decrease. And number 4 here, as well as a qualitative increase. In qualitative increase here, all the design and operating intentions are achieved together with some additional activities. Okay. The next is a part of a qualitative decrease. Okay. What it demonstrates here, qualitative decrease here, only some of the intentions are achieved, some are not. The next is the reverse, to logical opposite of intentions. This is mostly applicable to activities of, for example, a reverse flow or chemical reaction. It can also apply to substance, for example, poison instead of antidote, or D instead of Lee optical isomers. Okay. Other than complete substitutions, no part of the original intention is achieved, something quite different happens. Okay, that is HAZOP guided words. Okay, next, appendix 2 HAZOP parameters. Okay, HAZOP parameter constituted in two forms. This is my left hand side and this is my right hand side. Flow, pressure, temperature, level, viscosity, composition, corrosion, erosion, relief, vent, instrumentation, maintenance, maintainability, safety, utility, drainage, startup, shutdown, etc. These parameters must be controlled or mitigated through our mechanisms. That is a key purpose of HAZOP study. Okay, appendix explanation of HAZOP deviation, as we discussed in my earlier slide: temperature, pressure, flow, level, compositions, corrosion, origin factors, parameters. Now we are going to discuss deviations. The first deviation is the no flow. Okay, no flow, the wrong routing up blockade, incorrect slip plate, incorrect fitted NRV, ruptures a pipe, large pipe, equipment failure, CV isolation, etc. Second is a reverse flow. Okay, the reverse flow here, defective NRV, siphon effect, incorrect differential pressures, a two-way flow emergency venting, incorrect operations. The next is a more flow. Okay, more flow, increase of pumping capacity, increase suction of pressure, reduced a delivery head, greater a fluid density, exchanges or tube leaks, restrictions or plates, deleted cross connections of system control faults, etc. Then a less flow here. Okay, line restrictions, filter blockade, defective pumps, falling of vessels, valves, restrictor or orifice plates, density, viscosity problem, incorrect specification of the process fluid. Next is the more pressure. Surge problem, leakage from interconnected HP system, gas blockade, breakthroughs, inadequate venting, isolation procedure for relief vessels, defective thermal overpressure, positive displacement, pumps, fault open PCV, etc. Okay, next is less pressure. Okay, less pressure, generation of vacuum conditions, condensations, gas dissolving in liquid, restricted a pump, compressor section line, undetected leakage, vessel drain, etc. More temperature here. Okay, ambient conditions, fault or failed exchanger tubes, fire situations, cooling water failure, defective control, void heat control failures, internal fire reactions control failure, etc. Less temperature here. Okay, ambient condition, reduced pressures of fault failed exchangers, tubes, loss of heating. Okay, next is more viscosity or less viscosity first. Okay, so the less viscosity here. Less viscosity, incorrect material specification, incorrect temperatures. More viscosity here. More incorrect material specification and incorrect temperatures. Then composition change here. Composition change, leaking oscillations valves, leaking exchanger tubes, phase change, incorrect feedstock specification, inadequate quality control or process control procedure, etc. Okay, so the next is the contamination here. Okay, leaking exchanger tubes or isolation walls, incorrect operation of system in interconnected system, effect of corrosion or wrong additives, incourse of airs, shutdown and startup condition, etc. Okay, overhead corrosion and origins, cathodic protections arrangements, internal external corrosions protections, engineering specifications, stress, corrosion, cracking of fluid velocities. The next is relief here. Relief philosophy, process of fire, types of relief device and reliable relief valves, discharge locations, pollutions, implication, a two-phase flow. Okay, next is the instrumentation here. Control philosophy, location of instrument, response time, a set of points of alarms and trips and ability to change, time availability for operators, interventions, alarm and trip testing, trip control amplifiers, panel arrangement and locations, auto manual facility and human error, a fail-safe philosophy, etc. Next is the maintenance here. Isolation philosophy, drainage, purging, flushing, cleaning, drying, slip plates, access, rescue plan, pressure testing, work permit, system condition monitoring, lifting and manual handling, etc. Next is safety here. Toxic properties of process materials, fire and gas detection system, alarms, fire protection systems, firefighting, response time, emergency response plans and major emergencies, training, contingency plans, TLV of the process materials and methods of detections, noise, knowledge of hazards of the process material, first aid, medical resources, effluent disposal hazards created by others, adjacent storage process and plants, testing of emergency equipment, compliance with the local and national regulations. Okay, next is the utility here. Failure of instrument here, system nitrogen's cooling, water, hydraulic power, electrical power, water, others, contamination of instrument, airs, nitrogen, etc., telecommunications, heating and venting systems, and computer, etc. Okay. Startup and shutdown. Startup, normal shutdown, emergency shutdown, etc. The last year, but not least, is the sampling procedure and operator safety, time for the analysis, result, calibrations of automation samples, reliability, accuracy of the representative samples, diagnosis of the results, loss of sample flow, etc. Okay, appendix of 4 HAZOP record sheets. Okay, first column, if we can see here, my first column. Okay, first it demonstrates HAZOP a title, what is the present conditions, rank numbers, line and atom number, and design intent here, date and line and atom, etc. These are the parameters going to vet or evaluate pressure, temperature, flow, and composition. This is my initial conditions here. That is a design conditions. Then there is an operating condition. Okay, the design condition, pressure, temperature, flow, composition, and operating condition, pressure, temperature, flow, and composition. Okay. Okay. Now over here, first the reference and deviation here, and the consequences existing a guide, safeguard, and initial risk here, demonstrate and discrete. After setting up the control here, comments and action taken by the action parties, and then again what is the residual risk and risk rating, and then comments. Okay, risk levels, low, medium, high shall be identified as per the oil and gas company standard for the hazard identification study. Hazard we are going to discuss in my next couple of weeks. Okay, there are all safety instrumental functions identified in the HAZOP study which have high residential risk rating and falls in potential of the 4 and 5 in the risk assessment matrix. Shall be followed by safety integrity level study to determine the appropriate reliability required as per the guidance for the safety integrity level. Okay. Okay. Appendix 5 has action sheets. Okay. So based on the identifications in the initial risk, what identify in the initial risk with the existing safeguard. So what we have to do. Okay, first here is called the HAZOP action sheet here. This is the HAZOP action sheet. This demonstrates action sheet number and project title and location where we want to implement. HAZOP study reports. Here is the drawing number, action by, action date, its revisions or action number, etc. And furthermore here they demonstrate the atom, cause, consequences, action taken by, and here you can mention it, give a more detail here about the action taken, and reply prepared by the accepted or rejected here, and the date and time, and the incorporated into design or incorporated in the field, whatever then you need to mention over here. So that is the last HAZOP action sheet. Based on then you can identify what is the residual risk and risk rating in order to safeguard the plant operations. Thank you very much for your patience time. What we discussed today: HAZOP guideline words, HAZOP parameters, explanation, HAZOP deviation, HAZOP record sheets, HAZOP action sheets. Okay, next we are going to discuss HAZOP. It will take next couple of weeks. Okay. So these are few references: Qatar Petroleum, Doha, Qatar Oil and Gas Development Corporation, World Energy Outlook, U.S. Geological Survey, U.S. Department of Energy, Shell Budget, International Energy, Oklahoma Manual, State Oil Fact Sheets, NORSIC, Study of Oil, Pennsylvania, a liquid gas and second, natural gas from wellhead to burner tip. Together, everyone achieve more. Please do not hesitate to send me your feedback, comments at t.masood.dear. I have also provided my WhatsApp number. You may send me your input through my WhatsApp. Thank you very much for your precious time. Please stay at home, inspired and blessed. Thank you very much.